The rest is in your hand. How we draw the bending moment and shear force diagram. Clear everything? And now we have all the forces there. The best things to do, first draw a line. First you have a beam. All the forces are, we know what are they, which is, this is going to be a 2W. Is it 2W, yeah? Mm-hmm. And those equations. So if I was you, I would draw directly a bending moment and the shear force under the beam. Draw the diagram under the beam. And both diagrams should be under each other. So if I was you, this is going to be my shear force. And do some disconnection here, and this is going to be your bending moment diagram. Okay? As you can see here, that's the end of the beam. Yeah? Distance-wise, that's going to be A, that's going to be 2A, and the beam going to be end of a 3A. Yes? So shear force diagram to the shear force diagram, and the axis here, what's this, is in the Newton. And bending moment is in the Newton meter. Right, let's start with the shear force. For the first equation of shear force, second and third, and let's draw them. S is equal minus W over 2. W is a weight, yes? Load. So we can make it this way when you are. This is W. This is 2W. This is 3W, and so on. And this is a minus W, minus 2W, and also minus 3W. And when it goes to the bending moment, you need to have a line as well. As you can see here, for the bending moment, the best one is a W over 2. Yes, W over 2 or W. So this is going to be a W. W over 2 minus W over 2, W minus W minus 2W, yes, and so on. Let's start and solving the problem for the shear force. Watch me here. The first one between X, here is bigger than X equal by less than X. In order to solve it, is the best one makes an equation as equal by X equal by A. Does it make sense? Less than or equal than AX equal by 0 or bigger than 0. Why we do that? In order to solve it, yes? So we know that between 0 and A, shear force is a minus W over 2. Yes? So that's a W minus W over 2 is here. Half of the W. So the shear force, it would be continuous. It goes up to the A. And this is like a dotted point. Yes? And then from A to 2A become this equation. I already done this equation. Then it goes to this equation. Between A to 2A is a 3W over 2 is a 1.5 W, isn't it? So 1.5 W positive. That's a 1W, 1.5 W would be here. Yes? That's a 3W over 2. Which is going to be, this is almost dotted line up to here. At this point, you can see that and is here 1.5 W across between A, and now you can put equal in order to solve it. Yes? Why I'm doing that? Because you cannot solve it, we have to give a value. So it's the best way from A to 2A. When the x is equal by A. Between A and 2A, constant value 3, 1.5 W. Yes? So between A and 2A, which is here, it would be a line parallel to the x-axis, which is this bit. And then shear force between 2A equal by 2A and equal by A. I'm sorry, it should be 3A here, isn't it? 3A is a minus W. So between this part, it becomes a minus W, and this is a minus W here. You drop down. As you can see here, in order to understand how is it working, look at that. Shear force here, I put it a minus 2W, and it go right across, which is a minus 2W up to here. And then, what's the difference between half a W and 2W? How much is the difference between the half and 2? A difference between 2 and half?
1.5.
1.5. And you can see here, this distance is a 1.5 of the W. Yes?
Yeah.
Therefore, it's satisfying the conditions between the distance, one goes up, one goes down, which is I did it this way. And this distance from here to here is a 1.5, and this bit is a half. Yes, become a 2W. So 1.5 go down, another one, which is, this is in total, it become a 2W. Yes? And as you can see here, 5 divided by 2, how much is it? 2.5. Yes, 2 and a bit. And this is a 2 and a bit. Yes? Minus W and 1.5. So this is satisfying here, which is, this bit is a 5 over 2. And as you can see, a W goes down, this distance is W. Yeah? Okay. Then let's go to the equation of the moment. How are we going to draw the moment? Moment, how many equation of moment we have? One we have for the A, which is here. One we have for the 2A. This is A. This is 2A. And this is 3A. First, you're looking at the equation of moment. What does it remind you of this equation? It's the equation of the straight line, yes? Which is like a y is equal by mx, yes? M is a gradient of the line. Okay, in order to solve this equation, you have to put the values. This equation of a straight line, will work between 0 and A. So if, let's start this equation, how we solve it. Equation is M is equal by W over 2x. Am I right? So if, let's put the value, x is equal by 0. How much going to be M? If I put a 0 here?
0.
0. W2 times 0 is 0. If x is equal by A, where do I get this value? I get it from here, the range. If the x is equal by A, if I put the A in there, what would it be? WA over 2. A is a length, yes? Which is a number. W is a length as well. So, I call it a WA. I should call this one WA. This one another WA. This is a WA, WA, WA. You happy with that? Therefore, M is equal by WA. WA divided by 2. So, at the X is equal by 0, when X is equal by 0, M is 0. When the X is equal by A, value become, how much would it be? How much would it be? When the X is equal by A, M would be? Yes? WA over 2. W is a number, A is a number. So that's going to be a straight line which is going through the origins of the year. Happy? So you've done that. Let's go for these equations. This equation, when, if X is equal by A, what would be a value of the M? Anybody can find out? X, I put the A here. 4A minus 3A.
4A minus 3A would
A.
be A.
A divided by 2 times W become WA divided by 2. Yes? And if, what's the next value? Hamza?
What?
The next value I have to put for this equation. This equation operating in this range. First I'll use the X is equal by A. Second one would be X is equal by
2A.
Well done. If I put a 2A instead of X, 2A times 3 becomes 6A. 4A minus a 6A
It's 2, negative 2.
minus 2
Negative 2.
divided by 2A. And that would be a M is equal by minus a WA.
So can you explain how to get 2A if X minus 2A? Sorry, if X is equals to 2A, where is that from?
Can I say these two equations is between these range?
Yeah, they're between those, yeah.
Because we created. So in order to solve it, you have to put the values in there. Yes? Yes or no?
Yeah.
So one value starts from A and at 2A. Instead of X, first you put the A. 4A minus 3A become A. Divided by 2 become A divided by 2. Times W, WA2.
WA2, yeah. Okay.
And then I put this value, the last value, which is between 8 and 2A. When I put the 2A there, 2A times 3 becomes 6A. Take away 4A out of it, minus 6A, take away minus 2A. Divided by 2 become an A. Times this one become minus a WA.
Ah, okay. Yeah.
So between A and 2A, when there is A, when there is X is equal by A, I start with the WA over to same place, which is I end up with the previous one I started from here. Okay? And then I go to the minus WA. This is a minus WA. Yes or no? Watch it here. This equation of line, where is the equation of this line? You don't follow it. No?
It's the last.
What's the equation of this line? Where is this equation of line coming from?
Minus W.
Equation of this line.
Uh,
Where is the equation of this line? Where did I get this line? I solved these equations. Equation of the line would be this one. Equation of this line, I could take this equation would be belong to this line. Then we go for the range between 2A and 3A. I'll be using these equations. If Look at that, I put the arrows as well. If x is equal by 2a, what would be a value of the m?
It would be wx.
W? Look,
X would be.
they don't put the x.
No.
X, you put a value
Would
in.
be value. It would be 2a.
2a minus 3a times this one. What would it be?
W2a.
Why W?
So-
2a? It would be
WA.
W. 2a minus 3a
Yeah,
would be minus a WA, sir.
oh yeah. So because it would, yeah. That's right.
Be careful. Yes? And if x is equal by 3a, m is equal by? 0. If I put it instead of x, 3a,
It'd be 0. Yeah.
3a minus 0 times that would be 0.
0.
So, at the x is equal by 2a, x equal by 2a, beam is equal by 2a. Your value, it would be a minus WA, which is, this is a minus WA. You start from here. And you end up at the 3a. How much is the bending moment?
Would be back to 0.
Ah. Happy? Now, my question to you is, can I say when we bending this beam, probably the bending gonna go bend here, yes? Am I right? And this is gonna be in here. That's a bend gonna occur, yes? In here, and no bending in this end. Am I right?
Yep.
Reality, wouldn't be no bend here. Go like this. My question to you, where is the no bending, zero bending? There is some bending here, this place it would be a zero bending. Where is gonna be?
Between B and C.
Between, I know, probably is. Okay, where is it exactly in terms of the distance of the beam? No maths come to your help here. You have an equation of the line. Instead of y is a m. Instead of the x is a distance, we call it the x. At what point, he said between B and C, that's obvious. What point would it be this one? Think about it. How are you going to solve that? Have you got this equation? Let's put the equation of the lines there. Have you got the equation, the first one? What's the equation of this line?
M equals
Equal y.
W over 2x.
What's the equation of this line?
M equals W 4a minus 3x over 2.
What's the equation of this line?
W M equals W x minus 3a.
There would be a point, which is I call the point of, what do you want me to call it? N. The bending moment in this place is 0. Yes? This is the value of bending moment. Where is this point? Exactly. It's called analytical. Yeah? If you do it with a graph paper, probably you can find it. But with analytical, you will be so surprised, so precise. Give you a few minutes to solve it. You got the equation of the line. That's